In this problem, we're given several equations. Some are exponential, some are linear. We are to tell whether the equation is exponential or linear. Then we must tell whether the graph would be increasing or decreasing. If it's linear, we state the slope. If it's exponential, we state what the base is. And in either case, we need to state the vertical intercept. To remember the differences between linear and exponential, I've done a summary over here where I delineate each of the pieces of each function. For example, a linear equation is of the form y equals mx plus b. It's the number in front of the x, the m, that's always the slope. B is what you get out when you plug in 0, which gives you the vertical intercept. For exponential equations, they have the exponent, the variable in the exponent, and the equations of the form y equals ab to the x. The base is the b, and the vertical intercept is always what you get out when you plug in 0, and under these conditions, if you plug in x equals 0, you'll get the y value to be a. So let's give it a try. The first equation is of the form a b to the y. Now they chose to use the input variable y instead of x, but this is irrelevant. Anything of the form a number times a number raised to the input variable is exponential. So for the type of function, I'm going to choose exponential. The fact that the base is 4, remember the base is the number being raised to the exponent. 4 is bigger than 1. Anytime your base is bigger than 1, your equation or graph is an increasing one. So I'm going to select increasing. Since it's exponential, we can state what its base is. We said a few seconds ago the base was 4. So go down to base, type in 4. The vertical intercept, since we're dealing with exponential, remember is always 0, comma, whatever a is. A is the number not being raised to the power. So in this case, that's 5. So my vertical intercept would be 0, comma, 5. The next problem, just to do one more, notice that the variable is not in the exponent position at all. That means it cannot be exponential. In fact, it's of the form y equals mx plus b. My m would be negative 14. My b would be 210. So now that you see that this is linear, go down to linear. The fact that the slope is negative means that it's decreasing. Had the slope been positive, I'd have an increasing line. So I'm going to select decreasing. Over here, since it was a linear equation, we need to tell what the slope is. The slope is always the number in front of the x variable, or whatever the input variable is. In this case, it's x. The coefficient on x is negative 14, so type in negative 14. The vertical intercept is what you get out when you plug in 0. It's always the b in linear case, but it wouldn't be that difficult to plug in x equals 0. Negative 14 times 0 would be 0. You'd add 210 to get 210. So 0, comma, 210 is the vertical intercept. I'm going to do one more. The third equation is of the form ab to the x. So it's exponential. Would it be increasing or decreasing? Well, remember, the base, in this case, is 0.8. If the base is bigger than 1, it would be increasing, but my base is 0.8, which is not bigger than 1. As long as your base is between 0 and 1, you're going to have a decreasing exponential function. So I'm going to select decreasing because my number is bigger than 0, but less than 1. It's exponential with a base of 0.8. I'm going to select base. The base is always the number being raised to the power, so again that's 0.8. If you want to type in the 0, 0.8, that works too. The vertical intercept in exponential was the 50, the number not being raised to the power. In fact, if I plugged in 0, 0.8 to the 0 power is 1, and 1 times 50 is 50. So if my input is 0, comma, my output turns out to be 50, that would be my vertical intercept.